Hello students, welcome back. Let us continue with chapter 10 circles, the seventh sum of exercise 10.5. So it's been given that quadrilateral ABCD is cyclic. Obviously, the vertices A, B, C and D will lie on the circumference of the circle. But there is something very peculiar about this quadrilateral, that the diagonals AC and BD, they form the diameters. Now I need to prove that quadrilateral ABCD is a rectangle. So what do we need to prove in order to show that the given quadrilateral is a rectangle? That it is a parallelogram and any one angle is 90 degrees. Or you can even show that the opposite sides are equal, that is AD is equal to BC and AB is equal to CD, and any angle is 90 degrees, right? So now proving the angles as 90 degrees here, that is angle A, B, C and D as 90 degrees is very simple. How? See, if you look at BD, it's the diameter. Therefore, this portion from B to D, when I go through C, so BCD is forming a semicircle. Similarly, B to D through A is forming a semicircle. Therefore, this angle out here is 90 degrees because this is the angle subtended in the semicircle. Similarly, this angle is 90 degrees, right? So, this was for which diagonal? BD. Now, if you take into consideration this diagonal CA, so this is a semicircle. So, angle B is subtended in a semicircle, therefore, it is 90 degrees. Similarly, angle D is 90 degrees. So, the first part is proof, that is we have at least proved that the angles of this quadrilaterals are 90 degrees. Now, we need to prove that at least two sides are equal to each other, that is AD is equal to BC and AB is equal to CD. So, we will go about that proof, but for now let us go ahead and write for 90 degrees. So, I will say proof angle A is equal to angle C is equal to 90 degrees, angles subtended in semicircle using diameter. So, which is the diameter for angle A and C? It is BD. Similarly, angle B is equal to angle D is equal to 90 degrees. So, these are again angles subtended in semicircle using diameter AC, right? So, obviously, now let us mark this as 1 and let us mark this as 2. So, from 1 and 2, we are just clubbing and writing that angle A, B, C and D are equal. Therefore, angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degrees, and I will mark this as Roman number 1 because this is a part of the actual proof for the rectangle. Now, if you notice two triangles having base BA. So, which are the two triangles? I have AB, C and D. Each of these angles, so which are the two triangles? ADB and BCA. You have each angle as a right angle for these triangles. Therefore, in the right angle triangles ADB and BCA, I have AC is equal to BD. This is given that the diameter, because these are the diameters, right? So, the hypotenuse BD and CA are equal, and also I have this AB as the common side. Therefore, the two triangles are congruent to each other by the RHS test or right angled hypotenuse side test of congruence. Now, since the two triangles are congruent, I can obviously say that AD is equal to BC by corresponding pair of congruent triangles, and similarly I can later on take the triangles like this on base CB. Just excuse me for the drawing. So, if this is CB and I have DA, again you can prove the two triangles congruent by right angle hypotenuse side test, and you can show that CD is equal to AB. So you have opposite sides equal, that is AD is equal to BC and CD is equal to AB, and the angles is 90 degrees for quadrilateral ABCD. Therefore, the given quadrilateral, the cyclic quadrilateral ABCD is a rectangle. Now let's go ahead and write the proof for showing that the opposite sides are equal to each other. So the second side now, in right angled triangles ADB and triangle BCD, I will say angle A is equal to angle B is equal to 90 degrees from Roman number 1. Then I have hypotenuse BD is equal to hypotenuse, so this was ADB. So BD is equal to hypotenuse AC because they are the diameter of the circle. And I have side AB is equal to side AB because it's the, so it is ADB and BCA. So AB and BA, they are the common side, correct? Therefore, triangle ADB is congruent to triangle BCA by RHS test of congruence. Therefore, I will have what? AD is equal to BC. Let's mark this as, or this is through corresponding pair of congruent triangles. Let's mark this as 3. Similarly, I can say that AB is equal to DC. Let's mark this as 4. Therefore, from Roman number 1, points 3 and 4, what do I have? I have in quadrilateral ABCD, opposite sides AB is equal to DC and AD is equal to BC, and angle A is equal to angle B is equal to angle C is equal to angle D, which is equal to 90 degrees. Therefore, what can I say? Therefore, quadrilateral ABCD is a rectangle. Hence proved. So please take a look at the solution or the proof. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.